This episode of Climate Change 101 brought to you by organizations that care about climate science and want to share it with the world.
David, thank you very much. And we're going to do episode number 2 of our Climate 101 series today. And we're going to be talking about carbon dioxide. So why is CO2 central to global warming?
CO2 is central to global warming I'd like to use an analogy to sort of explain. If solar energy is the fuel that powers the Earth's furnace, then carbon dioxide is like the thermostat that changes Earth's temperature setting up and down. Climate scientists have understood for more than a century that increasing the amount of carbon dioxide in the atmosphere would cause the globe to warm. We see unequivocal evidence of that. The relationship between carbon dioxide and temperature in the ice core data record going back more than 800,000 years.
And where is that CO2 coming from?
Today, the increase in atmospheric carbon dioxide is coming mostly from human activities, including burning fossil fuels like coal, oil, and natural gas, as well as a large amount coming from cement production and a large amount coming from biomass burning, such as in deforestation, as well as other large-scale land use changes.
How do scientists know when they're measuring the CO2 concentrations that a carbon atom came from a fossil fuel as opposed to some other source?
Yeah, that's a good question. By monitoring changes in carbon isotopes in the atmosphere, scientists have shown that the rapid buildup of carbon in the atmosphere is coming primarily from burning fossil fuels. Specifically, they're observing an increase in the abundance of carbon-12 compared to carbon-13 in the atmosphere. Now, that may sound like jargon to your listeners, so let me explain. There are 3 types of carbon atoms called carbon isotopes. They differ from one another in that they have different numbers of neutrons in their nucleus. They all have 6 protons, but they may have 7 neutrons or 8 neutrons or 6 neutrons. We know that carbon-12 and carbon-13 are stable carbon isotopes, meaning they do not radioactively decay over time. And so we know they'll always remain carbon-12 and carbon-13 respectively. We also know that plants prefer carbon-12 over carbon-13 during the photosynthesis process. And so they take in much more carbon-12 during photosynthesis. And when they photosynthesize, they're taking those carbon atoms and using them to build plant structures. And so over millions of years, when the plants die or leaf litter falls to the ground, there's many billions of tons of plant structure falling to the ground where it gradually fossilizes, which is hence the term fossil fuels. That's where coal and oil comes from. And this is made up mostly of the carbon-12 atoms in fossilized form underground. So as humans mine and burn more fossil fuels, we're basically taking all that and putting it back up into the atmosphere. And so by monitoring this change in the ratio of carbon-12 to carbon-13, it's a clear indicator that the increased carbon is coming from burning fossil fuels and biomass burning by humans.
Final question for you. What other gases are responsible for global warming?
Yes, as I said earlier, a lot of the focus is on carbon dioxide because we put so much of it into the atmosphere, but there are other heat-trapping gases such as methane. And methane is a concern as well because it too has a complex molecule, and so it's even more efficient than carbon dioxide. It's about 30 times greater in its heat-trapping capacity than carbon dioxide. But luckily for us, methane is much less abundant in the atmosphere than carbon dioxide. We measure methane in parts per billion, whereas we measure carbon dioxide in parts per million. I could also add that when we combine methane with all the other known human-produced heat-trapping gases, that adds up to about 1 watt per square meter, or one little Christmas tree light bulb for every square meter of surface area in sustained forcing on the planet. And carbon dioxide is about twice that amount or 2 watts per square meter in sustained forcing. So CO2 is about twice as great as methane and all other heat trapping gases combined in terms of a radiative forcing on the planet. And altogether, that's a combined total of about 3 watts per square meter in radiative forcing on the system. And I can put that number into context for you if you'd like.
Sure. Why don't you? We've got about 30 seconds left. Why don't you do that?
Yeah. So to put that number into perspective, scientists estimate that over geologic time, on roughly 100,000 year cycles, Earth's orientation changed relative to the sun. And as you tilted the northern hemisphere towards the sun, that increase in exposure to sunlight averaged over the whole planet was about 1 watt per square meter, that one little Christmas tree light bulb per square meter. So if it took Mother Nature about 1 watt in radiative forcing to warm up our planet out of an ice age, today we see that humans have exceeded that amount by about 3 times what it took Mother Nature to warm up our planet. But the difference is the rate of warming is projected over the course of this century to be about 50 times faster than Earth warmed due to Mother Nature's forcing. So that helps put it into context.
David, thank you very much, and we look forward to having you on further episodes of Climate 101.
Thank you very much. My pleasure.